Hello, good morning, guys. So in the last class, we discussed about Ether channel, right? About Ether channel, we saw that this is a method by which you can combine multiple physical ports into a single logical port. Okay. We can combine multiple physical ports of a switch into single logical port. So we saw three methods or three protocols. One was LACP, PAGP, and third method was static. LACP stands for link aggregation control protocol. Your PAGP stands for port aggregation protocol. And static, it is a method. Okay. Your LACP, it is an open standard, being supported on all vendors. Your PAGP, it is Cisco proprietary. And again, the static is a manual method, so it is again open standard. Yes. Then your LACP has two modes. One is active and second one is passive. Your PAGP has two modes, auto and desirable. And your static has only one mode, that is on. Okay. In case of LACP, if both the switch ports, means if both the switches they are working in the active mode, then your Ether channel will come up. If one is active, one is passive, then Ether channel is come up. And if both switches are working in passive mode, then the port channel will not come up. Okay. Similarly, when you're using PAGP, when both the switches are in auto mode, Ether channel will not come up. If one is auto and second is desirable, then your Ether channel will come up. And if both are desirable, then the Ether channel will come up. And in case of static, the Ether channel will come up only if both the switches are in on. Clear? So this was what we discussed about Ether channel. After Ether channel, we discussed about port security. So port security is a method to secure your switch ports. Means the ports of your switch you want to secure from unauthorized access, right? So we use port security. In the port security, the first thing we saw what we can do to secure the ports. We can manually shut down the unused ports. Whatever ports we are not using, those ports we can shut down. We can go to the interface and give the shutdown command. Okay. So we can say manually shut down the unused ports. And we can just simply go to the interface. Let's say fast Ethernet 0/1 and give the command shut down. Second thing, what we can do, we can enable port security to allow only one MAC address. And what you're going to do, you'll go to the interface. You'll give the command switch port security, and that's it. This will enable your port security on the interface. Third thing, what we can do, we can bind a port with the host using MAC address. So when you bind a port with the host with the help of MAC address, what is going to happen? Only that particular MAC address will be able to communicate through that port. If any other MAC address is trying to communicate, that will be the violation of your port security. Okay. So in that case, interface F0/1. First, you will enable the port security. So you'll say switch port security. Then you will bind it with the port. So you'll say switch port security, MAC address, and whatever MAC address you want to bind with that port. Okay. Now, if there are few systems like 2 systems, 5 systems, you can bind each and every port with the host. But again, if you are having a lot of systems in your company, so this is not a reliable way of configuration. So what we can do, we can use the sticky method. Or I can say bind ports with hosts dynamically. Means we are going to automatically capture the MAC addresses. In that case, you will say interface F0/1. Then you enable the port security. You're going to say switch port security. And then you'll give the command switch port port security. Then you'll say MAC address and you'll give the word sticky. And the sticky word, this will automatically capture the first MAC address that will communicate through that port. Okay, then that particular configuration will be saved in your running configuration. To make the configuration permanent, you will save it in the NVRAM by giving the right command or copy running configuration to startup configuration. Clear? We discussed about port security violation mode. So one mode is the shutdown, one is restrict, and the third mode is protect. In the shutdown mode, if there is a violation, the port will go down or the port will move to the error disable state. After that, even if your legit system tries to communicate, it will not come up. So even your legit system will not have the communication. To bring the port up, first of all, you'll go to the interface, then you will give the shutdown command, and after that, no shutdown command. Then only your interface will come up. Otherwise, it will not come up. Okay. In the restrict, when there is a violation, the port will not go down, but also your unauthorized system will not have the access. The port will not go down and the unauthorized system will not have the access. And there will be logs will be generated. In case of protect, exactly similar to restrict. Unauthorized system will not have the access, port will not go down, but logs will not be generated. This is the difference. To change this mode, you will simply go to the interface. Let's say F0/1. By default, the mode is shutdown. By default, your port security mode is shutdown. So you'll go to the interface and you'll say switch port security, violation, and then the name of your violation mode, whatever name you want to give. Clear? After this part, we discussed about Inter-VLAN routing. In the Inter-VLAN routing, we discussed about a method, router on a stick. Router on a stick. Okay. So we had a scenario like this was your router switch, and we were having two systems. This was your 10.0.0.1, 20.0.0.1, VLAN 10, VLAN 20, correct? So now for communication between these two, for inter-VLAN communication, we have total three methods. First is a router with separate interfaces. In this case, what you'll do, you'll have a router, and let's say if you're having two VLANs. So for two VLANs, let's say this is VLAN 10 and this is VLAN 20. So for each and every VLAN, you will use one interface, one for VLAN 10, one for VLAN 20. And on the switch, what you're going to do, this particular port, this will belong to your VLAN 10. This port will belong to VLAN 10. This will belong to VLAN 20. Similarly, if you want to use this interface for VLAN 10, so you will use this port also, VLAN 10, and this port also VLAN 20. And then whatever gateway you want to assign, let's say to this PC, I want to assign the gateway 10.0.0.2. That you will configure here, and 20.0.0.2 you will configure here. But there is a limitation in this. What if you are having more than 2 VLANs, 5 VLANs, 10 VLANs? So routers are not having that many interfaces, either 2, 3, or 4, not more than that. Okay, so this is not a reliable way. So we go with the router on a stick method. Means we'll use only one interface, and that single interface will divide into multiple interfaces. And those interfaces, we call them as a sub interface. Okay. So in this case, again, if this belongs to your VLAN 10, this belongs to your VLAN 20. So means this one port, this has to carry the data of both VLAN 10 and 20. And when a port has to carry data of multiple VLANs, we have to create that port as a trunk. This is clear? Okay. After that, again, now we need two gateways and we are having only one interface. So if this interface is your Z0/0, so you will create two sub interfaces. First one is interface Z0/0 and dot, and any number you will provide. Let's say for VLAN 10 I want to use, so I'll say .10. Then first of all, you'll have to inform your router that this particular sub interface is carrying the data of which VLAN. So you'll give the encapsulation method. So you'll say encapsulation. We are going to use .1q, and then for VLAN 10. Then you'll assign whatever IP address you want to assign. Let's say you want to assign the gateway 10.0.0.2. So you'll say IP address 10.0.0.2, and whatever is your subnet mask, and that's it. This is done. Okay. Similarly, one interface, one sub interface, you will create interface z0x0.20. You will give the encapsulation method, encapsulation .1q20, and you will assign the IP address 20.0.0.2 and your subnet mask. And these values, these IPs, you will use in the gateway for the PC. For these, you will use the gateway as 20.0.0.2 and here 10.0.0.2. This is clear. The third method, this is the second method. The third method is your layer 3 switch. We haven't discussed this because not part of your syllabus. But right now you can understand, instead of having this scenario, instead of having a router, you can use a layer 3 switch also. What you can do, let's say I can connect again two systems, right? This is VLAN 10, this is VLAN 20. Let's say 10.0.0.1, 10.0.0.2, sorry, 20.0.0.1. Clear? Now what I can do, I can create two SVIs in my switch, or I can even use these physical interfaces as my gateways, because it is a layer 3 switch, so it will support IP addressing. Okay. And then you just have to give one command, that is IP routing. And this will start routing between your VLANs. Okay. Let me show you the practical also. So first of all, we'll assign the IPs. Assign the IP addresses, and gateway will be 10.0.0.2, 20.0.0.1, 20.0.0.2. Now on this switch, see, like a router, it is also having initial configuration dialog, right? Enable configure terminal. Now what are the interfaces? Interface F0/1. So you'll say interface F0/1. Now if you try to, yes. No signal. Very strange. Okay. So you'll say interface. What is happening? So then it went to the interface. If you try to assign the IP addresses, you'll see the command is not supported. If I hit question mark also, it will say unrecognized command. Because by default, even your layer 3 switch ports, they are working as layer 2. So to disable layer 2 features, you will have to give one command, that is no switch port. Once you give this command, this port will act as a layer 3 port. Okay. And now if you try the command IP address, it is supporting the command. Give the IP address, let's say 10.0.0.2.255.0.0.0. Okay. And port is already up, so we do not need to give the no shutdown command. Similarly, the second port F0/2. So interface F0/2. To disable layer 2 features, we'll say no switch port. Then you assign the IP address 20.0.0.2.255.0.0.0. And already up, so we don't need to give the no shutdown command. This is clear? Okay. Now if I go to my PC and try to check connectivity with my system, I mean my layer 3 switch, I have the connectivity, right? But if I try to ping 20.0.0.1, will I be able to ping? No, because my switch has taken the IP addresses, but still it is not performing the routing. So what you have to do? You have to go to the switch. In the global configuration mode, you have to give the command IP routing, and it will start routing. This is your third method for inter-VLAN routing. Clear? Any doubt in this part? You just have to go to the switch ports, say no switch port command to disable layer 2 features, then assign the IP addresses and give the IP routing command. That's it. Clear? Online people?
Yes, sir.
Okay. So this was the part we discussed in the last class. Today we'll be starting with some more security concepts. And first concept is your DHCP relay agent. So what is a DHCP relay agent? Your DHCP relay agent is useful whenever your DHCP server is available in some other network. Okay. Because so far we created the DHCP server. So what did happen? We created DHCP on the router and we provided IP to the clients. So it was in the same network. But if your DHCP server is available in a different network, in that case, what you're going to do? Okay. Let's say, for example, because initially our scenario was we were having a router. This router we created as a DHCP server. We took a switch and then we had some client systems. This was the topology, correct? Okay. So in this case, when you create DHCP on the router, they will still be in the same network. But what will happen if your DHCP server is in a different network? Let's say, for example, let me use a server in this network. This is your server. Okay, we are going to create DHCP on this server. What if your DHCP server, because this will be a different network, right? Let's say, for example, this side you are using the network 10.0.0/24, and here the network is 20.0.0/24. So in this case, how your DHCP is going to work? Because whenever your client will request for the IP, it is going to send DHCP discover message. The DHCP discover message is a broadcast, and router does not forward a broadcast packet. Router will never forward that broadcast message on this side, right? And the DHCP offer again a broadcast, so router will not forward that particular message this side. So how they are going to get the IP? So for that purpose, we have to see about DHCP relay agent. Means this router we have to create as a relay to relay the information, to pass on the information from one network to another network. So how we are going to do that? See. So for this, what we are going to do, first of all, we'll create a DHCP server. And let me assign the IP addresses first. So this side I'll use the IP 10.0.0.1. This side 20.0.0.1. 20.0.0.2. And these clients, they will get the IP from the server, DHCP. Okay. So let me assign the IP addresses. On the server, desktop IP. Guys, am I audible? Online people?
Yes, sir.
Okay. So we are going to assign the IP addresses. So I'll go to the server, desktop and IP configuration. Then I'll assign the IP 20.0.0.2 and gateway I'll assign 20.0.0.1. Then I'll create a DHCP server on this server. So I'll go to the services, DHCP. Now in the default gateway, I want to create DHCP for these clients. So for these clients, what will be the default gateway? 10.0.0.1. Okay. So I'll give here 10.0.0.1. DNS information, it is optional, but still if you want, you can provide. Then the starting IP address. So what will be the starting IP address? Means the IP address from where you want to start the assignment. So I'll start the assignment from 10.0.0, let's say, for example, 50. Okay. Then what is the subnet mask you want to assign? So this is the subnet mask. All the configuration done. Save the configuration and switch on the DHCP service. Clear? Okay. Now go to this router, and this I'll call it as a relay router. This is your DHCP server. And this one here we have relay router. Okay, I'm just giving this name for the understanding purpose. There is no special router as a relay router. Okay. So go to the router, enable, configure terminal, and host name I'll say it relay. Okay. On the interface Z0/0, what will be the IP address? 10.0.0.1. No shutdown. On the interface Z0/1, it will be 20.0.0.1 and no shutdown. Interfaces are up. Okay. Now to these clients, we want that IP address should be provided from this server in the different network. So if I right now, if I try for the DHCP IP, my DHCP IP will fail. It is saying DHCP failed, APIPA is being used. Now what is APIPA? APIPA stands for Automatic Private IP Address. Okay. APIPA stands for Automatic Private IP Address. And the range of APIPA starts from 169.254.0.0 till 169.254.255.25. So if you see any IP address from these, that means it is an APIPA. So APIPA is a feature of your operating systems, so that whenever your DHCP server is not available or not responding, they will automatically assign some IP address, random IP address. And that will always be in the range 169.254. Okay. And this address is known as APIPA. And even with this address also, your systems will be able to communicate. Okay. Is that clear? Okay. But you see, my DHCP has failed. If I try again also, it will fail, and I'm still using APIPA. Because my router is not forwarding, you can see. If I go to the simulation mode, and if I try the DHCP again, my DHCP discover message has been generated. You can see this is a DHCP discover packet. This packet will be broadcast, so forwarded to everyone. All of these PCs will drop, even your router will drop, because router will not forward this message on the other side, as it is a broadcast message. And the router has each and every interface in the separate broadcast domain. Okay. So now what we'll do, we'll configure this router to relay this information, to provide this information on the second network, so that these clients can get the IP address. Okay. So on which interface, or yes, on which interface of the router the clients are connected? Z0 by 0. So you have to go to the interface Z0 by 0. And you'll tell the router that for IP address helping, you are going to need IP helper address. And what is the server IP? 20.0.0.2. That's it. This is configuration for your DHCP relay. One command. Okay. You have to go and say IP helper address and the IP of your server. Okay. Now your router will help these systems to get the IP address. It is going to forward the DHCP messages. We got the IP 10.0.0.50. 51. So how it is working? If you check, if I go to the third system, desktop, IP configuration and DHCP, discover message generated. Now, as soon as this discover message going to the router, router will not drop this message, because this time router know where the DHCP server is available. Okay. So what your router is going to do? See, earlier it was not having any sort of IP addresses in the source and destination, but your router created this packet. That source is 10.0.0.1 and destination is your server. Means it is relaying this information to the server. Okay. So this packet will go to the server. Server will respond with the offer message. Okay. Then this offer message will be delivered. See, it dropped here, and now it is going to forward this side. So in between, router is working as the relay. Okay, this is the message. ICMP echo. Why ping started? Did we ping? So you see, the server has given the IP address, offering the IP address 10.0.0.52. Okay. Before it was showing some other packets, because if you see, I haven't filtered any packet. So it is showing all the packets. Okay. So this is the offer message. Now your server is, your router is going to again relay this information, because from server 20.0.0.2, this packet came to the router. Now router is broadcasting this packet, and you'll see these both already have the IP address. So they are going to discard. This did not request for IP. So this is going to discard. So this system will take this offer, and you'll see this is your DHCP packet outbound. And this DHCP information, it is going to show the acceptance of the IP address with the request packet. Okay. So it is going to send to the router, and router is going to relay this information again to the server. and server is going to acknowledge this request, and your client will get the IP address. Still no IP address. This acknowledgement is coming. Once this acknowledgement is there, you have the IP address. So again, the 4 messages are being exchanged. But this time, your router in between is working as a relay to provide the information to help the systems to get the IP address from a different network. Okay, because not always your DHCP server will be available in the same network. Right? Because in company, you are having multiple different networks. So you are not going to create multiple different DHCP servers. On a single server only, you'll configure all the networks and you'll use the relay options. Is that clear? Yes.
So when the IP request released from the system and go to the router, and from the router it will go to the DHCP server. So while going to the DHCP server, will it be still a broadcast message?
Unicast between router and server. This will be a unicast.
Okay. So
only router is going, whenever router is delivering the message like your offer message. So again, router doesn't know who is the destination. So that time he will broadcast, but router know where is the server. So the discover and the request packet, they will be unicast between router to server. Is that clear? Okay. Clear to everyone? All right. So DHCP relay agent is clear. Only one command is there. You have to go to the client side interface and say IP helper address and server IP. That's it. Okay. This is the command. So I'll say interface and interface name and number. And this interface is your client side interface. On this interface, you'll go and you'll say IP helper address, and this is DHCP server IP. That's it. This is the configuration. And this particular this is your client side interface. Here. Okay. Now we have the DHCP server and we considered everything. Now the next concept is DHCP snooping. So what is DHCP snooping? This is a method to prevent unauthorized DHCP server in your network. Let's say, for example, right now your network is working very fine. And each and every system, if you see, they are getting the IP address from your actual server. Okay. And if you see, they will, if they try to communicate with the server, they are able to communicate. They are having the communication with the server. Now, at some point of time in the company, there is an employee who is not really happy because these kind of things happen in the enterprises. What he'll do, he'll install his system with a server operating system. Let's say my laptop, I'll install a server operating system and I'll create a separate DHCP server in my server, in my system. And I will connect this to the network, right? Because I have the access to the network, right? I'm a part of company, so I can use the network. I'll install my system. In my system, I'll install a server operating system. Can be a Linux server, can be a Windows server. And then I'll create a DHCP server. In that DHCP server, what I'll do, I'll just change this gateway information. I'll not change anything else. I'll change this gateway information. Means whenever this PC will request for the IP, they will get the first offer that is going to reach them. Correct? So means they will take the offer from my server. Once they take the offer from my server, I'll change the gateway and I'll give the gateway to my system. So they will disconnect automatically from the DHCP server. See, connected. Now let's say IP address also I'll take from the company network only. I'll take the IP address from company network only. First time failed. Why it is failing? Oh, port is still not up. I have the IP address. Now, looking at this IP address, I'll get all the information. What is the network running in my company? First thing. Second thing, what is the subnet mask? What is the default gateway? And what is the DNS information? All these information I got, right? Now, what I'm going to do, I'll create my DHCP server. Their default gateway, I'll say 10.0.0, for example, 11. Instead of 10.0.0.1, I'll say 10.0.0.11. DNS server information, I'll give it exactly same. IP address, I'll give exactly same. Let me start from 50. Okay. I'll save this information, switch it on. Okay. Done. This my DHCP server is known as ROC DHCP server. This is clear. Now, what will happen when these PCs, because right now they are having IP from the main server, the correct server. So if I try to ping, they will be able to ping. They will have connectivity with the company server. But as soon as their lease expires, because with the DHCP, we know there is something called as lease time. The time duration, as long as a system can use that IP. After that, system will have to renew the IP. So it will have to re-request. So what will happen? If I go to static and if I go to DHCP again. Okay. Server is on. Oh, subnet mask, sorry. Okay. So turn it off, again turn it on. Received the same IP 50, same DNS information, same subnet mask. But if you see the default gateway changed, and as soon as the default gateway changed, and if you try to have communication with the company server, there is no chance. Why? Because whenever a PC has to communicate with a different network, let's say go to internet or communicate with server, they will always send the packet to default gateway. So earlier the default gateway was your 10.0.0.1 router. A router knows where is the server, but right now the new default gateway is your server. So your company network will come down instantly. Let's say he has installed the network or the DHCP server today. So today everything will be working fine. No one will know anything. But next day when they come and turn on their systems are going to request for the IP. And each and every system in the company, they will get the IP from the fake DHCP server. See, 11. The entire network is going to get the IPs like this. And your entire network will be down. They will not have communication with the internet. They will not have communication with the server. And in companies, all the client systems, they are connected to the servers, means they are able to log in if they have connectivity with the server. You cannot log into your system without having connectivity with the server. This is one of the features in your Windows server, okay, known as Active Directory. So you will not be able to log into your system, means your network is down, you cannot work. Now what to do? So we have to prevent these kind of attacks, prevent fake DHCP servers. So for this purpose, we use a feature or a security feature, we call it as a DHCP snooping. Okay, so how do you enable DHCP snooping? First of all, what we are going to do, we are going to enable this feature, and we are going to say in the global configuration mode, IP DHCP snooping to enable the DHCP snooping in your switch. Then after this, you'll say IP DHCP snooping to enable it in VLAN. VLAN and VLAN ID. Okay. Once enabled, now we have to tell your switch that which port is having the correct DHCP server. Because if we see here in this case, which port will be delivering the correct DHCP information? The one coming from the router means F0/5. This is the port that is going to provide us the correct DHCP information. And other ports, they can be fake. If there is a DHCP from other ports, that means it can be fake. So what we'll do, we'll go to the switch, go on this interface, and we'll say this is the trusted interface. This is the interface that is trusted. So you are going to say interface and the trusted interface name. And then you'll say IP DHCP snooping trust. Okay. Now your switch is also having one relay options. So you have to disable that option, and you have to say IP. I mean, for disabling, we have to say no IP DHCP snooping information option. So your switch will not forward the DHCP information from other ports. Okay. So these are the commands for your DHCP snooping. Once you enable this DHCP snooping and you create a trusted interface, if there is any DHCP offer from other interfaces, your switch will instantly drop those messages, those offer messages. Okay. So let's go and check. I'll go to the switch, CLI, enable configure terminal. First of all, I enable DHCP snooping. So I'll say IP DHCP snooping. Then enable it in VLAN. So IP DHCP snooping VLAN. Right now we are having only one VLAN. So VLAN 1. Then disable the relay option. No IP DHCP snooping information option. Then go to the trusted interface. So according to our scenario, the trusted interface is F0/5. So we'll say interface F0/5 and I'll say IP DHCP snooping trust. Now this is my trusted interface. So now what is going to happen? As soon as the client systems will try to request IP again, they have the correct IP configuration. And if you see, this server is going to create an offer also. Okay. If I go to this system, discover message generated, switch will forward everywhere because it is a broadcast, and you will see this has also generated the messages. What are the messages? One is the ARP and second is the ICMP. Let me just filter out all these messages so that no confusion will be there. Only DHCP messages we will see. So this has already received the IP. Okay. Now check. So if I go on the system and request for IP from DHCP, you'll see both of these. It has accepted the DHCP discover message, right? And this packet is still not reached the DHCP server. So this will take time. And that's why your systems, they will take the first DHCP offer. But this time what your switch is going to do, switch is going to drop if there is a DHCP offer message from this server. This is the offer message from the server, but it is from the untrusted port. So your switch is going to drop this message. And this DHCP message, this will come from the trusted port. So your switch is going to forward this message. And your system will get the IP. Okay. So this is how your DHCP snooping works. Is it clear? Any doubt? No? Okay. Next, small option. Again, these are small topics. Dynamic ARP inspection. Okay, so what is dynamic ARP inspection? So let's consider a scenario. You are having a switch. Okay, you have a PC and you have a server. Okay, let's say this is connected to F0 by 1. This is connected to F0 by 2. Having the IP 10.0.0.2 and MAC address, let's say B. This is having IP address 10.0.0.1, MAC address A. Okay. So initially your PCs will be having ARP cache, correct? So if we consider the ARP cache about PC1, it is going to have information IP and MAC, correct? This is what ARP cache. Similarly, your server will also have a ARP cache. In that there will be the information IP and MAC. And your switch is going to have a CAM table. In the CAM table, there will be information port and MAC address. Correct? This is what your CAM table is. Or you can call it as a MAC address table. So initially, everything will be empty. No one will know about anything. But as soon as they start communication, what will happen? Your ARP table is going to have the entry. Your CAM table is going to have the entry. Means your switch is going to have the information that on F0 by 1, A is connected. F0 by 2, B is connected. And your PC1 is going to have the information that, okay, 10.0.0.2 is having the MAC address B. And your server is going to have the information 10.0.0.1 is having the MAC address A. This is clear how this is going to happen because we have discussed this thing many times. How your switch is going to forward the frames and how it is going to create the MAC address table. This is clear to everyone? Okay. Next, what is going to happen? The problem arises when there is a hacker in your network. When there is a hacker in your network. This hacker will take the IP address again from your network, let's say 10.0.0.3 and MAC address is C. And this has been connected to the port F0 by 3. Okay. So your switch is also going to record on port F0 by 3. I have MAC address C. Okay. Now your hacker will make use of a special type of ARP. I think everyone remembers ZARP, gracious ARP. Does not require any ARP request. It is an ARP response and used to announce the IP to MAC binding. That this is my IP address, this is my MAC address. Okay. So your hacker, it is going to generate a ZARP and it is going to say that my IP address is 10.0.0.2 and my MAC address is C. It is going to broadcast this information. This information will go to the switch. Switch is going to broadcast this information. Means this ZARP is going to go this side as well as this side. So this system, it is not going to respond it. Your PC1 will see this ZARP and will check. Okay, 10.0.0.2 is having what MAC address? C. Means it is not B. It is C. Correct? And next, it is going to generate a second ZARP and it is going to say in that this time I'm 10.0.0.1 and my MAC address is C. And when it is going to broadcast this message, this time your server is going to change the information and say it is C. Okay. So this is what it is known as ARP spoofing. ARP spoofing means your hacker spoofed the ARP cache of your PC as well as your server. Now, what is the problem that is going to arise with this thing is, let's say PC1 wants to communicate with server. So PC1 is going to generate a packet. In that packet, it is going to have source IP information, destination IP information, source MAC, and destination MAC. Correct? Source IP, your PC will say source IP is 10.0.0.1. Destination IP, it is going to say 10.0.0.2. Source MAC, it will say it knows its own MAC address, that is A. And destination MAC address, it is going to check in the ARP cache and it will see destination MAC address is C. This packet will reach the switch. What your switch is going to do? We'll check who is the destination. C. For C destination, on which port I have to forward? Means this side. Now what your hacker can do, it can manipulate the data or steal this data, and also it can forward one copy of the data on the other side for the server, so that there is no suspicion, that there is no communication. Okay. To not be a suspect, it is going to forward the information also. But before forwarding, if it wants, it can manipulate the information also. Your hacker can manipulate the information also. Okay, given to the server. Now your server is going to respond. Again, server is going to generate a packet. And in that packet, there will be source IP, destination IP, source MAC, and destination MAC. Server is going to say, my source IP is 10.0.0.2. I want to talk to 10.0.0.1. My own MAC address is B and destination MAC address is C as per my ARP cache. Again, this message will forward this side. What your switch is going to do, check the destination MAC, and your switch is going to forward this message. Because destination MAC address is C, right? Looking at the ARP cache, CAM table, it is going to forward on port F0/3. And again, your hacker can keep this information or manipulate this information and send on the other side. So you will never come to know if there is some person sitting in your network who is stealing all your information. Means, let's say, if this is my PC, this is my server, and if I'm trying to take telnet access, or if I'm trying to log in, so I'll have to provide usernames, passwords, all these things, right? And everything is going through the hacker. So he can have all the information. Okay. And this kind of attack, it is known as MITM. That is your man in the middle attack. This kind of attack is known as man in the middle attack. So what this hacker? Yes.
Hacker can get the information once we do the telnet. But what if we use the SSH?
Even if you use, everything is going from hacker only.
But he doesn't know the password. If we use the
See, SSH is a secure protocol. But again, he can have decryption tools. Okay, clear? So this kind of attack, we are not just talking about one protocol. There is many data, let's say HTTP websites. So HTTP websites, they transfer all the data in plain text. For example, let's say you are going to Facebook, you're going to Instagram, any website you're typing your usernames and password, and everything is going through the hacker. You are trying to make a payment, you are typing your UPI pin, going through the hacker. You are accessing your internet banking, typing in your usernames, passwords. So everything is going through him, right? Is it clear? So to prevent this, we have this dynamic ARP inspection. So what happens in case of dynamic ARP inspection? Your switch will make use of a database that is created by your DHCP snooping. Because your switch does not understand IP addresses, right? But in this DHCP snooping database, you will find the information about IP address as well as MAC address. Means to what IP address, which MAC address has been assigned. Sorry, to which MAC address, what IP address has been assigned. So if there is an entry in this DHCP snooping database, your switch will allow the ARP. If the entry doesn't match in the database, your switch will drop the ARP. So if your switch will drop this GARP, there will be no spoofing. No spoofing means no man in the middle attack. So to prevent this man in the middle attack, we are going to use this feature, dynamic ARP inspection. And this dynamic ARP inspection is going to make use of your DHCP snooping database to filter out the ARP packets. Is that clear? Okay. So first of all, we'll see, this is layer 3 switch. I'll go to the switch and I'll say enable show IP DHCP snooping binding. And you'll see your switch has the information to this MAC address. This is the IP address. So means only ARP from these systems will be forwarded. If any other system generates ARP or GR, that will be dropped. Is it clear? So how do you configure dynamic ARP inspection is, first of all,
Sorry to interrupt.
yes.
But when a hacker connects the system to the network, doesn't he get the IP from the DHCP?
Yes, it gets.
Then that would the table would change.
Why would change?
And once it
So
applied,
again, it sends an ARP. It is going to say my MAC address is this, my IP address is this. So if in this database it is not matching.
so you mean to say even though if you connected that
Even though if we connect it, the ARP is going to be matched with this particular database. And if it doesn't match, this will be dropped. Okay. So you're going to say IP ARP inspection, and you're going to enable it in your VLAN. Whatever is your VLAN, VLAN 1. Okay. Then you'll go to the interface. Let's say interface, whatever interface you are having. That is, let's say, for example, F0/5 is your trusted interface. Means wherever your trusted clients are connected, all those places you will make trusted, all those interfaces. Let's say F0/1 to 5. Okay. So I'll say interface range F0/1 to 5, and I'll say IP ARP inspection trust. That's it. This simple configuration. This is clear. Once dynamic ARP inspection is enabled, everything will be compared with this DHCP snooping database. If it is matching, it is good to go. If it is not matching, it will be dropped. Is that clear? Clear to everyone? Online people? Okay. Now this. So we'll say IP ARP inspection, then VLAN and VLAN ID. And after that, interface, and you can say range or any single interface also you can create. That is up to you. Then we'll say trusted interface. And after that, you'll say IP ARP inspection trust. Okay. These are the commands for configuration of IP ARP inspection. Is that clear? Yes. Okay. Now next we have SNMP, Syslog and AAA. These are some small theory concepts, so we have to understand them. So first is SNMP. What is SNMP? SNMP stands for Simple Network Management Protocol. Okay, this is used for network management. So basically we are having these two protocols. One is the Syslog and second is the SNMP. So what is your Syslog protocol? Basically your router or switches, they generate logs. Whatever tasks are happening in the router or switch, they generate logs, like your interface coming up, interface going down. Okay. If you see, for example, interface F0/10, and if I say shutdown, so it is giving me a message. This is a log basically. This is a log. If I'm saying no shutdown, again a log. Means whatever tasks are happening in your router or switch or your device, everything is being logged. Even your each and every device, even your Windows, Linux, every operating system also generate logs. Okay, like your Windows, it has event viewer. What are the events going on in your Windows system? So each and everything will be visible. You can have the logs, like Windows logs. See, each and everything. Everything is being logged. Let's say if I want to check application related logs, so you'll see lots of logs are there. You see number of events, 42,000. Means continuously each and every single thing it is recording. Anything that is happening in my system. Okay. It is going to record that information. Is it clear? Okay. So these are the logs. So logs are basically why logs are useful. What is a log? Basically, log is a record of an event that is happening in your system or your device. Okay. So all your systems or devices, they keep a record of each and every task that is happening in them. And why logs are important? Logs are important. Let's say at some point of time you want to check. Let's say there was your network down, or you want to check whether if something suspicious or malicious is happening in your network. So how do you check? If you see the logs, let's say your company stops working, like your company shift overs at night 10 a.m. or 10 p.m. After that, if something is happening and there is a log, you will know that no one should have done that. Means something is going on. Okay, so logs are basically a record which you can check. Like you might have heard, there are audits in the company. What are they? They check everything. What are the things happening in the company? What are the timings, and how do they know if there is something wrong using these logs and all these things? Means looking at the record only they come to know. So this is our digital record. Your logs are your digital record of the devices, whatever is happening in the devices. Okay. Now, what is the difference between Syslog and SNMP? Both are almost similar, but logs, they are automatically generated. You cannot ask your system to give you logs that I want logs related to this application only. You cannot tell that. Or at any point of time, you cannot ask your system to give you logs, or you cannot put any configuration using the syslog protocol, because syslog is basically just for logs. Anything happening, they will give you a log. That's it. But SNMP, it is a network management protocol. With the help of SNMP, you can manage the devices, you can put out configurations, and you can ask the devices for a particular type of event or configuration. Let's say, for example, right now my company is working and routers and switches are working there. So I want to check that on a particular router, what is the CPU uses, what is the bandwidth uses, okay, what are the RAM uses. So I can just particularly point out a particular thing and ask for that, and your device is going to provide you that. Means your SNMP manager, there are two things. One is the SNMP manager and second is the SNMP agent. Okay, means there's one device that is known as SNMP manager, and remaining devices, let's say your router switches, they are having a software installed in them, that is your SNMP agent, and they will communicate with each other. If SNMP manager wants some information, it will send a GET request that I want to get this information, this particular information, and they will respond. Your SNMP agent will respond with the required information. And if there is something suspicious, or let's say I have set an alert that if CPU uses are 80%, then send me an alert. So as soon as there is CPU uses 80%, these are going to send an alert message. Those alert messages are known as trap messages. Means whenever there is an event, they are going to send trap messages. They will send trap message to the SNMP manager. This manager is configured such that it is going to send an email or SMS to your admin, and your admin will come to know. So means if we are not having this SNMP protocol, your network and admin has to manually go and check each and every device, what is the CPU uses, what is the RAM uses, if it wants to monitor. Means the entire time of your admin will go in just monitoring. But when we are having SNMP, the monitoring part is left for the SNMP. Your admin can just focus on troubleshooting the issues, not on monitoring. Okay, so this is why SNMP is used. Syslog is just for the logs, but your SNMP is a network management protocol, has much more better uses than your Syslog. Is that clear? So now we'll discuss about SNMP, then we'll see differences between Syslog and SNMP. So if we discuss what is SNMP, so simple network management protocol is an internet standard protocol used for monitoring and managing network devices. Okay, connected over IP. SNMP collect data from different network devices like your routers, switches, firewall, printer, server, CCTV, wireless access points that are SNMP enabled. Means all these devices, these are SNMP enabled devices. They support SNMP. They have the SNMP agent software installed in them. Okay, and your SNMP manager can install them, organize them. With a set of operational standards for management, SNMP aids in the fault detection and analysis. Obviously, if there is a fault, SNMP agent is going to send a trap message to the manager. Manager is going to send an alert to the admin. And admin, instead of focusing on monitoring, again can directly focus on troubleshooting. Thus, SNMP is an integral part of interoperability between both the monitored and monitoring devices because they interoperate with each other. They communicate with each other. SNMP generally uses UDP protocol and the port number 161 and 162. And it uses the TLS, transport layer security, to secure the communication. Your SNMP send entire data in plain text, but your SNMP encrypts your data. Okay. Or DTLS, datagram transport layer security protocols also used as for the security. Is that clear? Okay.
So you use both features.
No, it uses UDP 161, 160. Huh? Transport layer security. So UDP also transport layer protocol, right?
But it is not that much secure.
Hmm?
It is not that much secure.
UDP, we didn't come with the security. UDP and TCP, there is no difference like security. Only reliable and unreliable difference. Okay, security can be provided. Security can be provided, right? If you are having a VPN, you transfer whether via UDP or TCP, doesn't matter, right? So security is not a difference between TCP and UDP. Only you can say reliable, flow control, error control, these kind of things. These are the differences, not your security. Okay, because security protocols are completely different. They can provide security to any protocol. Okay. So why do we need SNMP monitoring tools? So network admins generally manage the devices in a network and allocate and free up ports and interfaces to ensure continuous uptime and bandwidth of free network operation. Means your network admin has to do all the tasks manually. Closely monitoring SNMP devices is a major part of this, and your network admin has to closely monitor each and every device. So SNMP monitoring requires an admin to configure SNMP agent to send the monitoring data to SNMP manager. Now we'll configure all your devices, your router, switches, firewall. In them, they are already SNMP enabled. So we'll have to configure just that where is the SNMP manager. Once you configure this, anything happening in those devices, they will automatically send the information or monitoring data to the SNMP manager. Okay. Since the network management tool takes care of monitoring, admin can focus on performing corrective measures. So monitoring is part of your SNMP. Your SNMP is monitoring your network. Now your task is to use the corrective measures if something is happening. Is that clear? So why your SNMP monitoring tools are necessary? Automatically discover, monitor, and manage network devices. Once you configure, your SNMP is going to monitor all your devices automatically. Monitor key performance metric at the device and interface level. Means at each interface, what is the bandwidth level, bandwidth uses, what is the CPU uses, what is the RAM uses. These kind of things you can monitor with the help of SNMP. Then obtain complete visibility and granularity into the performance of network devices. Means each and every device you can monitor their performance. And you can monitor, okay, which device is having higher RAM uses, which device is having less RAM uses, all the things you can monitor. Configure threshold limits and generate alert in case of anomalies. So you can configure particular limit that if the usage reaches 50%, 60%, you send me an alert. So SNMP agent will send the trap message to the manager. Manager will send alert to the admin. Is that clear?
It is working for mobile also. If we increase our data usage, it will show.
Your mobile operators, they tell you 50%, 90%, this kind of thing. No, that is different. That is not actually SNMP, but still they are monitoring your data uses. So you can say kind of it, but not exactly.
It happens in mobile operating system also so that we cross our limit of.
Yeah, you can set limits in your mobile data.
Yeah.
Because your mobiles, they are having the feature that you can set a limit that if I use 500 MB, then give me an alert. So they are going to monitor you. But again, there is monitoring and monitored device is one only. But in case of SNMP, we are having a manager different and all other devices are different. Okay. So how does your SNMP works? So traffic flow across your network in different sources, right? SNMP communicate with the whole network and the devices in it. It is going to communicate with all the devices in your network, but the devices should be SNMP enabled. As mentioned earlier, SNMP is pre-configured on devices, and once the protocol is enabled, the device will store the performance states. It is going to store the performance, means again CPU uses, RAM uses, okay? And each network server will have multiple MIB files, management information base. Means this is a database where they will store entire information about the performance and the alerts. Okay, your SNMP agents. The device MIB files are required to fetch the monitoring data. Means whenever server or the SNMP manager is asking for some information, they will look for that information in the database and they will send that information. Okay. Working of SNMP revolve around its components, wherein each component contribute management of resources. Because SNMP manager has to continuously talk with all the devices. So each component is contributing in the management process. Not only your SNMP manager, but each and every device that is having the SNMP agent, they are contributing in the management process.
Where exactly this SNMP manager will be?
It is a controller software.
Controller. So it will be available in all the devices.
Not all the devices. See, router switches, they are agents. Controller you will have to install.
Controller we have.
Yes. Controller we have to install. Your agents, they will be by default available. They are already available. SNMP works by sending protocol data units. Remember PDU, known as SNMP get messages, whenever it wants to receive or take out some information from the agents. Okay. To the network devices that respond to SNMP. So if your manager is sending the get request, then your SNMP agent will respond with the particular required data. All these communications are tracked and network monitoring tools use them to fetch data from SNMP. Okay. Your SNMP manager is going to use certain tools like your OIDs to inform the SNMP agents that I want this particular information. Okay. Now one diagram will be there and everything will be explained with this one diagram. This is how the scenario is. Means all your managed devices, that could be your routers, switches, and firewalls. They are having these SNMP agent softwares installed. And these SNMP agents, they are going to form this management information base where they are going to store all the live information. Means what is the CPUs, the RAM use, okay, all these information. Now, anytime your server wants to get some information, it is going to send a GET message and your agents are going to respond. And if I have set some limit, let's say I have set some threshold limit, and if it is crossed, your agents are going to send the trap message. Okay, and if there is an anomaly, some devices going to the some devices going down or new devices being added, so again they are going to send the trap message that this is the new information. So anyway, your admin can just manage from a one place, that is from your SNMP manager. This is how your SNMP works. Clear?
Where do we have to install the SNMP controller?
On a device like your system, you can install.
In the system itself.
Yes.
There is no need of turning on router.
No.
Okay.
It is a manager. So your admin is not going to sit on a router.
Yeah.
Right? So what are the components? Again, first is the SNMP manager who is going to manage entire network. Then we have managed devices like your router, switches, firewall, all these devices. Okay. So what is SNMP manager? SNMP manager is a central system used to monitor the SNMP network. Okay. Also known as network management system. An SNMP manager is responsible for communicating with SNMP agent implemented network devices. It runs on a host on a network. So host is a system. The manager requires the agents get responses, set variables in them, and acknowledge events from them. So again, it can configure the agents. It can get some responses from them. It can set some values in them. Okay. And it can acknowledge the events. Okay. If they are sending a trap message, then it can acknowledge them. What are the managed devices? A managed device is a SNMP enabled network unit entity that is managed by the SNMP manager. These are usually routers, switches, printers, and wireless devices. Then what is an SNMP agent? An SNMP agent is a software process that responds to SNMP queries to provide status and statistics about a network node. Okay. SNMP agent plays the most important role in the management because it is the one that is going to provide all the information to the SNMP manager. They are locally located and associated with SNMP network devices from which they collect, store, and transmit monitoring data. Data is transmitted to the designated SNMP manager whenever required. Anytime your manager is asking some information or there is an important event, they are going to send the information or transmit the information. What is the MIB? So a management information base forms an integral part of the network management models. So an SNMP MIB is a structure that defines the format of information in exchange of SNMP system. Entire information will be stored in your SNMP MIB. Then whenever server wants to get some information to particularly display or tell the SNMP agent that this particular information I want, it is going to use the SNMP OIDs. Okay. So OIDs are identifiable by the strings of numbers separated by dots. So this is like ID, like you can say IPv4 address kind of thing, because IPv4 is also ID, right? Address, identity. Similarly, we are having the object identifiers, OIDs, to identify that if I want CPU uses, I'll give this number. If I want RAM uses, I'll give this number. Okay. Now, what is the difference between SNMP and Syslog? So one main difference is your Syslog will give you a historical data. Means if something has happened already, then only log will be generated. There is no real-time tracking. But in case of your SNMP, you will get real-time information, because any point of time you can tell the SNMP agent to provide you that information, and SNMP agent is going to respond to you with that. Is it clear? So SNMP allows for remote monitoring of SNMP allowable devices on the network, means all SNMP enabled devices. What about Syslog? Syslog is a different protocol that can be used for exchanging log messages. Okay, it is used only for log messages. SNMP is used to alert critical actions like the mentioned HSRP state change. If there is a particular, your active router is down or up. And Syslog is also collected, which allows me to dig deeper to figure out why the HSRP state changed, because your SNMP will give you only alert that your active router is down, but your Syslog is going to provide you the information why the active goes down. If there is an interface down, the router is down, what is the problem? So that you can see with the help of logs. Then SNMP works on pool and resource mechanism, means it can send the information as well, and it can receive the information. It can ask for a particular information. But your Syslog works on push mechanism, means they will just send you the logging information. If something happened, log generated. That's it. SNMP is referred to get real-time information, but Syslog is generally giving you historical data. End device configuration can be performed via SNMP. You can configure the devices, like you can reboot the systems, but with Syslog, you cannot do that because it will only generate logs, no other task. SNMP traps are shared in binary format. Okay. And entire communication is plain text. SNMP is secure. This is insecure. This is active, means you have interaction. In this, you do not have any interaction. So passive. Your SNMP uses UDP port number 161 and 162. Your Syslog uses TCP and UDP port number 514. Okay.
Sir, if we use TCP protocol, which used to be secure also.
See, again, the same thing. TCP and UDP, there is no difference like security. TCP and UDP, there is no difference like security. That is reliability and non-reliability. Okay. Now, last concept of the day. Simple 3 terms you need to understand. AAA. Authentication, authorization, and accounting. So what is this AAA? This is basically used for authentication, means verification of the devices. Means, let's say, if I'm going to my bank website, my bank will be verifying whether I'm the correct user. And how the bank will verify? By asking me usernames and passwords, right? So this is what is authentication, means verification of the user. Second term is authorization. So authorization defines the level of access. Once you log in, how much access you have, what are the tasks you can perform. Because if you log in internet banking, you cannot completely control your account, right? You are given some particular amount of control, right? So that is what is authorization, means giving you level of access. What are the privileges you have? What are the actions you can perform? Then there is accounting, means keeping a record of everything. That is what you are doing. Let's say, for example, let's take a telnet example. You are accessing a telnet router. So first will be authorization. According to authorization, you have to verify by the password or username or password, whatever you give. Now, after that, whatever user you log in with, that user privilege is going to define how much access you have. Because in your routers, there are total 15 privilege levels. And if you are having privilege level 1, you cannot even go to the privilege mode. Okay. And if you have privilege level 15, you can directly go to the privilege mode and start with the comments. So there are 15 privilege levels. So that is going to define your level of access, that to what commands you have the access, to what commands you do not have the access. Okay. So that is authorization. And accounting is going to keep a record, what time you log in, what is your username, how much time you stayed active on the connection, what are the commands you type, and what was the output of those commands, everything. Okay. So understand, AAA is a standard-based framework that is used to control who is permitted to use the network, what they are authorized to do, and capture the actions performed while accessing the network. everything. This is authentication, authorization, and accounting. So what is authentication? The process by which it can be identified that the user which wants to access the network resource is valid or not by asking some credentials such as usernames and passwords. This is authentication. Common methods to put an authentication on console port, aux port, or VTY lines. We put on VTY lines, we put usernames and password, and whenever you take the access through the telnet or SH, you are being asked for usernames and password. As network administrator, we can control how a user is authenticated if someone wants to access the network, whether he can access only through password, usernames and password, or you will use a AAA server that is going to verify for you. Then what is authorization? It provides capabilities to enforce policies on network resources after the user has gained access to the network resource through authentication. Means after the authentication is successful, authorization can be used to determine what resources the user allowed to access and the operations that can be performed. Means basically what the user can do. What is accounting? It provides a means of monitoring and capturing the events done by the user while accessing the network resource. It even monitors how long the user has access to the network. The administrator can create an accounting method list to specify what should be accounted for, to whom the accounting record should be sent. Means what are the things you have to record and to whom that record has to be sent. This is accounting. Means keeping a record of all the tasks or all the events performed by the user while the user was logged in. And the protocols we use for the AAA purpose are Radius, TACX, and TACX Plus. These are the three protocols. And you'll see the configuration in your CCNA. Right here, we don't have this. Is it clear? Too much of information today. Okay. All right. So this is all for today. That's it. Half of our time we just took in the yesterday's part. So that's why it looks a lot, because we discussed yesterday's part, then we discussed today's part. Okay. So any doubts, online people? All doubts clear? Very good. All right. See you guys tomorrow. Have a great day.